normally we kind of start out just with, if there's networking opportunities, if somebody's looking to hire anybody, we usually kind of give opportunity for people to mention that, and if people are looking to connect with them. So I don't know if anybody's a hiring manager or got job opportunities that they want to offer up for people. And then the other thing is if there's any announcements that anybody wants to make.
That's the Scalability Summit is September 16th. I think you just missed out on getting a cheap ticket. And then LastCon is October 25th, 26th.
We should have discounts for LastCon pretty soon. So cool.
And way off in the future, Data Days Texas 2020 is January 25th.
Okay, and so a friend of mine, Jason Crouch, is the person who provided the pizza for us. He wasn't able to make it today.
Yeah.
And he is, I'll just say it a little bit, he's a real estate agent. He runs the, he's one of the owners of the Austin, Texas homes, the realty with, he's got
Cool.
a dozen or so real estate agents that work for him. And they're good friends of ours. They're pretty good people. They're, if you're in the market for a house or interested in buying, selling, there's cards here, or they're also been a good resource for me to just find out what's going on in the market and what things are like. And if you followed any of that recently, house prices in Austin are nuts. It's kind of crazy what's going on, but so there's some cards here, and I guess I will just leave them up front here if you want to pick one up. And I think Jason came to one of our meetups several months ago. And he'll probably show up at subsequent meetups, so he's kind of volunteered to be our at least the occasional stopgap sponsor if we run out of other people that bring food. So I caught up with him this week, and he managed to get everything lined up just last minute yesterday. So I think that's about all I have. So if you want to
Cool.
introduce.
Yeah, my name's Logan. I'm with AustinTechVideos. I probably know a lot of you, but we're doing a joint meeting tonight, so I just want to say a few things. Really looking forward to Chris and his talk. He's spoken at several of our, I don't know if you can see it, but Longhorn PHP conference happens every March or April. So next year's going to be number 3 for us. We haven't announced anything too set in stone yet, but I believe ticket prices are posted, or sign up for the email and you'll get notified when tickets go on sale. LastCon is the other thing, definitely want to plug. As you mentioned, it's a really great event here in Austin, so definitely check that out. As part of our meetup, we give away, so it's open to everyone, everyone, but JetBrains, if you do any sort of Python, Ruby, PHP, or Java or whatever, it's a 1-year free license from JetBrains. So that will be raffled off at the end after the talk. So yeah, thank you, Chris. Really appreciate you stepping up this month to give the talk. And yeah, looking forward to it. Thank you.
Cool. All right, thanks. So I'm Chris. I manage a small software engineering team at an HR company. That's my day job. A while back, I used to work at a pretty big company, and we got DDoS quite a bit, and so I got to wear a lot of hats, trying to put out fires. I learned a lot pretty fast. And then after I left, back there, I kind of helped put some mitigation platforms in place. Learned a lot of things, and then since I left that place, I kind of started helping a couple people out, and then I put this little LLC together, HiveWin, which is kind of a tax write-off for me. It's made me dozens of dollars. But I've learned quite a bit, and I'm just hoping to share some of this with you. So in my presentations, I like to put a lot of links so you can dig out more information. So there's a PDF you can get from this URL, right? You'll get an HTML page, and with a link, you click to PDF. Yeah. So has anybody here ever had to mitigate a DDoS attack? No? Good, I don't wish it on anybody.
No. Interacted with people suffering from it? Yes.
Yeah. It's a humbling experience, to say the least. And the key is, to be as prepared as you're going to be, as you can get, right? I'm going to break the bad news. There's no magic bullet here to address this, but we're going to look a little bit at the threat landscape and things we can do to harden ourselves, aka defensive countermeasures. All right. So basically, the point of a denial of service attack is to take your business offline. And it's a sizable headache. If you look at InfoSec in general, traditional InfoSec, you want to try to build a system that cannot be breached. Well, it's not realistic. It still feels pretty attainable, right? Like, so if it's a web application and you do all the OWASP best practices, you're probably going to be okay, right? When it comes to DDoS InfoSec, you're trying to build a system that cannot be taken down, right? And if you look at the sheer number of hosts on the internet with the Internet of Things, which we're going to touch on, it becomes kind of a pipe dream. So the other thing is, I've seen a lot of people kind of gravitate toward those firewalls, like web application firewalls. They don't help you. They will make things worse, actually, because a lot of firewalls are designed to do real-time packet analysis. They're not designed to deal with like a sheer volume of sudden onslaught of packets. If you can still have a firewall, but you need to have a DDoS mitigation solution in front of it. So, all right. And the thing is, when the internet was first invented, it was academia, military. The goal was not to have the entire world on that ARPANET thing, right? So a lot of the protocols were designed early on as being very trusting. And as people have abused protocols, we've had to bake things into them to make them a lot less trusting, right? So why, you might ask, would somebody want to take your business offline? There are a few reasons, right? You got conflicting interests. Somebody is in the same business as you are, and they have an interest in seeing you, go down. You'll see a lot of that online casinos. They DDoS each other a lot. You got, so competition is similar kind of gig. Extortion is a big thing. So you may get an email one day that says, give me, 10 Bitcoin by next week, or we will take you down. And sometimes they make good on that, sometimes they don't. Axe to grind. People don't like the fact yet that you moderated their comment away on a vBulletin forum, right? People have all kinds of reasons. They don't like that you do business with company X, right? Distraction is also a big thing, right? So at any given time, people want to try and breach your network. A good way to facilitate that is to distract you with this onslaught of packets and all these requests coming into your network. It'll pollute your logs. It'll keep your entire DevOps team completely busy. And in the meanwhile, they're just going to come through a good old SQL injection and exfiltrate all your users, right? And it's going to be a lot harder for you to do forensics on that. So yeah, these are a few of the motivations.
So which one's number one? I'm just curious. Is there a number one?
It's been a while since I've looked into it. I can't tell you which one of those motivations is number one. It'll depend. And the thing of it is you got to look at which one of those motivations your business is the most susceptible to, right? Because what's number one, you know, it may be hacktivism because of, you know, PayPal, right? Well, you're not PayPal, right? So, you know, you got to look at those motivations and see kind of where your vulnerability is. So I have some news from the 2016. Anybody follow Brian Krebs, InfoSec, right? Yeah, he does a lot of really awesome in-depth articles. Highly recommend everything he does. He's dug into the Mirai botnet and kind of tracked down its author. But yeah, so he was a victim of HTTP floods, and he was on Akamai at the time, and Akamai was like, they just, you know, they cache everything, so they just served everything. But it was like, you know, terabytes of data in a very short amount of time. So now he moved to Project Shield. Anybody familiar with Project Shield? Yeah, so if you're like a nonprofit and you do something good for the world and you want to, you know, shield yourself from DDoS attacks, they'll have your back for free, right? So yeah, this botnet that was involved in the Krebs attack, it was based on a 12-year-old SSH vulnerability, right? It was a bunch of cameras that got breached based on a 12-year-old SSH vulnerability. Yeah. And we're going to look a little more into that. And then October 21st of 2016, people got productive at work because Twitter went down. And Twitter went down because they were using DNS. And Dyn got attacked, so Twitter went down. And we're going to look at how we can avoid that. So yeah, I got links to a couple more articles if you're curious about all this stuff. So yes, the Internet of Things has become an increasingly pain in the rear. You got millions of cameras. It could be anything. It could be cameras, DVRs, routers. Is anybody familiar with UPnP? Universal plug and play, right? So often if you buy a video camera, you know, to like a baby monitor or some kind of security camera, and you know, the kind of camera where you can be at the restaurant and you can, you know, view what's going on. The most cost-effective way to do that is for you to connect directly to your camera on your network. So UPnP is a protocol that most routers support, like your home router at home, and it allows a device on the network to say, hey, I would like to open a port directly to me. Can you do that? And your home router will say, yeah, sure, go ahead. So now you have port 8000, for example, that's wide open to the world to go straight to your camera, right? So now if your camera does not have great security, and guess what? It doesn't. Guess what's going to happen? Well, you know, guess how botnets get built, right? This is a big irony, right? A security camera is used to breach into your network. So there's a lot of that going on. You know, shared factory default passwords, decade-old vulnerabilities. It's hard to secure because you got cheap components, you got limited CPU and memory, so encryption is not very convenient. You often have inconsistent network connectivity, so you can't always reliably push upgrades to it. Yeah, so there's a funny Twitter account called Internet of Shit. Okay, and they chronicle the universe of silly Internet of Things out there. So here is a smart cookie oven that you can control from your phone. Here's a smart thermometer. And it gets especially funny around Halloween. Let's say you have a Ring device, right? So now it's a bunch of kids doing a denial of service on your phone. Yeah. There's a lot of these things out there. It's scary, right? You get your fridge or TVs. So beyond Internet of Things, there are a lot of other threats as well. They're still going strong. Is anybody familiar with the WordPress pingback protocol? Yeah, a couple people. Okay, yeah. So this is a protocol that allows, you know, one WordPress site to say, hey, you link to me, yay, and now I will link back to you, and woo, right? There's no verification there. Basically, you can send that pingback verification to millions of WordPress sites out there to say, hey, send this pingback verification to the victim host. And a million WordPress sites out there are like, yeah, sure, no problem. Yeah. It's bad. It's tragic. And then you've also got millions of compromised desktops, laptops, and server. You got web applications that get compromised as well, right? Including advertising networks. Sometimes you will see malicious ads being put on advertising networks they have some client-side code that can take down any site that the bot master wants to take down. Okay, so we're going to look at some types of attacks. So you have your OSI stack right here. And the attack vectors are going to start at layer 3, I think, TCP and UDP. And we're going to look at threats on both of those. So it's important to understand the differences between TCP and UDP. So in pink, I'm going to have what I call a spoof zone, where it is possible to have a fake source IP on a given packet. And then the green zone is going to be an area where you must have real hosts for things to happen. So in TCP, let's say you have host 1 and host 2. When host 1 connects to host 2, there's going to be a TCP handshake. And then once the handshake has been done, there's going to be data exchange between those two hosts, right? So the handshake is an eminently spoofable zone. Every leg of the handshake could be spoofed with a fake IP address. But then for data exchange to actually happen, over an existing socket, then yeah, you do have to have real hosts. Okay, that can't be spoofed. And then here's UDP. So UDP, it's great because it's just packets, right, with application data in there. So the whole zone is spoofable. It's terrible. So the lifecycle handshake, yeah, so we just kind of touch on all these things. TCP, the lifecycle, just to remind you, for a TCP handshake is host 1 will send a SYN packet to host 2. Host 2 will say acknowledge and send a SYN packet back to host 1, an ACK and SYN combo packet back to host 1, and then host 1 will send an ACK packet back to host 2. So that's the big, and the key here is that every leg of this handshake is spoofable. So here's some basic attack patterns, right? You're going to have attackers, and then there's going to be you. So these attackers are going to use real machines, maybe a handful of real machines, to craft a bunch of junk packets with fake IP addresses, right? So there's going to be like spoofed junk packets. And they're going to send you hundreds of thousands of SYNs per second, hundreds of thousands of ACKs per second, right? And then every time you're going to go like, what's that? Same thing with ACK SYN packets. You're going to go, what's that? And then in some cases, you're going to try to respond to those packets to IP addresses that don't even exist, right? So the biggest impact here is really CPU and memory. That's kind of what hurts the most. Bandwidth a little bit, but these packets are pretty small. So it's mostly your CPU and memory that's going to really hurt. All right, so now let's look up a layer, application layer attacks with HTTP. So you're going to, this time for actual HTTP attacks to happen, HTTP floods, you're going to need real hosts to make that happen. You cannot spoof those, right? So here's your attackers, here's you. And you're going to have hundreds of thousands of those infected machines, right? And they're going to send a bunch of gets per second, a bunch of posts per second, and you're going to try to send some responses, but you're not going to be sending 200,000, responses per second. You're probably going to die at, 20, if that, right? So, but that's going to, put strain on your CPU, your memory, your bandwidth. I mean, those attacks are devastating. So beyond HTTP floods, there's a lot of really fun things you can do at the application layer. Actually, this would be not even the application layer, it's still at the socket layer. You could just open 20,000 idling connections, right? What's the default U limit on a Linux host? How many concurrent connections do you have by default? Yeah, 1,024. Yeah. Unless you change that at a system level, right, or at a user level or system level, it's going to be by default that, right? So, so if you write a program that literally opens 20,000 sockets and just kind of idle there, you're probably going to take that, that web server down, right? Hash DOS. Has anybody ever heard of what hash DOS is? It's a packet that it's like an evil crafted hash map. Where you have like major collision on all the keys. And whether it's PHP, whether it's Java, almost every language supports a concept of a hash map. And you can basically take a server down to 100% CPU with a couple of requests with hash DOS. So I have a link to the exploit. It's pretty gnarly. Now there are ways to harden web servers against that. So if you follow that article, it'll show you how, what you can do with everything. Slow Loris. Anybody heard of this one? Okay. So this one's also pretty fun. You open a connection and then you send a header like once every second, right? And you do that times 10,000 connections basically. And so as long as a header keeps coming over the request, the web server is going to keep that connection open, right? Because sometimes if you do 20,000 idling connection, the server is going to close them down within a couple seconds if it's well configured, but most are not. But for those who are well configured, you can try and do a slow race against them and you can take them down pretty badly. So, and also TLS exhaustion attacks. So, now with let'sencrypt.org, right, it's becoming more prevalent for everybody to put TLS on their site. Google will rank you better. The browsers will say, you're secure, or this site is not secure, because TLS means everything when it comes to security, right? Yeah, but anyway, I get the pros of TLS, but there are some performance impacts of it. It does add an extra handshake in a request, and you can do attacks against this handshake. So TLS exhaustion attacks are a thing, and it's a big nightmare, so. Yeah, so the thing to keep in mind is most web applications do have abysmal performance. Like right now, I could say I could take down about 90% of most sites out there with just a laptop. It's not, that hard. All right, so now let's look at UDP. So UDP is fun. So here, there's no transport to attack, really. It's just packets with application data in there. And we're going to look at a couple of things: reflection and amplification, the combination of the two. Reflection is bad, amplification is bad. When you put the two together, it's dumpster fire. So we're going to explore what these things do. So here I have a couple links to some known UDP amplification attacks for NTP, DNS, but there are a lot more protocols that rely on UDP. You got a lot of gaming protocols. You got a lot of real-time data sharing protocols that use UDP. So let's look at reflection. So here's you on IP 1234. And here are a number of attack bots. Each one of those attack bots are going to say, I am 1234. They're going to pretend to be you. Each one of those bots is going to craft hundreds of thousands of UDP packets pretending to be coming from you. And they're going to send those request packets at a number of badly configured UDP services out there who will take requests from anybody. You get a lot of NTP servers, network time protocol, who sit wide open. You got open DNS resolvers out there, and there's other types of services. And all these hosts are going to send hundreds of thousands of responses to you because, you requested all this stuff, right? And it's going to eat up your bandwidth, and it's pretty tragic. So I always recommend, do not route UDP traffic into your network. Try to work with your upstream ISP and their upstream ISP to be like, don't want UDP. If you have to run DNS, try to go through a third-party provider. But yeah. So now let's look at amplification. Amplification is so much fun. So if you don't have amplification, it's pretty simple. You have host 1 and host 2. So host 1 is going to send a small request to host 2. That small request just says, hey, what time is it, right? And host 2 is going to say, it's noon. And so it sends a small response back to host 1, right? Small request, small response. Okay. Now with amplification, so it's the same thing. You're going to have a small request, but here, this time around, the small request is going to be, who have you seen? It's a command called munlist that you can send to an NTP server. A badly configured NTP server has a command called munlist, and it tells you all the hosts that it has seen since it last started. Yeah. Oh, yeah. Oh, yeah. So it's a huge list, and boom, huge response, right? So now attackers love that because it's a small cost to them with like a great benefit to them, right? So now when you combine reflection and amplification, right, you take this scenario that we had earlier with only reflection, now you're going to add reflection with amplification, and now you have much bigger requests coming back to you, right? Spoof requests coming to you. So, yeah, not fun. All right, so what can we do? Fixing the Internet of Things would be a good thing. There is a standard called MUD. I looked at it recently. It looks like the RFC is still moving forward. It's called Manufacturer Usage Description. Basically, if you have a camera on your network, this camera has no reason to be issuing an HTTP request to your website. It has no reason to do that, right? It should only be talking to one specific host, for its configuration and things like that. So MUD allows you to specify that, codify all that, such that you can kind of deploy these specs across different networks, and the networks could start enforcing those policies, right? So if you're an ISP and you see a bunch of packets coming from, somebody's house, coming from a device, trying to go through to some website, then as an ISP, you have the ability to kind of block that, right? So that's kind of the vision behind MUD. I have a link to the RFC. Beyond that, it's kind of like, okay, well, maybe if you're putting an IoT into the world, maybe you should get some security certification. Same way where you have you have to go through the FDA to put some drug on the shelves. Maybe there should be some law here to do that. It would kind of suck, right? But if we don't regulate ourselves, if we don't become better, guess what? Government is going to come and regulate us. So these are all things worth keeping in mind. Another thing that we can all try to do is to reduce reflection and amplification vectors. There are open DNS resolvers. I have links to initiatives to track those down and get them closed down. If you have NTP servers out there, there's ways to use a secure template to do that. Okay, spoofing is also another thing, right? I should not be able to make a packet with a source IP that is not mine and have that packet go all the way to some destination. The network should be enforcing this. And most networks actually do, right? This is why these RFCs were drafted and ratified, and these standards have been deployed across the world. But there are still pockets of networks out there that allow spoofing. And as you work in the industry, if you get you know, you work with a web hosting partner or you're working with a, you know, uplink provider, try to see if you can make a fake packet and have that packet go, you know, go somewhere, right? And if you see that, hold them accountable with your dollars. All right, WordPress. Like I said, the pingback verification protocol, it would be nice to just make that go away. It was exposed in 2014 and has been exploited. To this day, it's still being exploited. And you got millions of WordPress sites. I mean, it's the world's easiest botnet. You don't even have to work at it. Yeah. All right, so that was the threat landscape. Now we're going to look at hardening ourselves. Okay. Let me have some vodka. All right, so here are some basic strategies that I've worked with over the years. Number one is to reduce and diversify your attack surface. Then we're going to look at DNS redundancy. We're going to see how what happened to dying DNS doesn't have to take you down. Then we're going to look at web performance and scaling, monitoring, and then we're going to look at some potential solutions for mitigation platforms. All right, so first thing, reduce and diversify the attack surface. So the first thing we're going to look at is to reduce the attack surface. So consider your network. I said before, this is kind of what you might have today, where you have network, you know, this is your network with a bunch of services on it, and you may have all kinds of services on it. You may have like UDP services for NTP, DNS, RTP, right? You could have TCP services, HTTP, SSH, FTP, SIP. You could be running all of those things on your network. What I recommend is to Nmap yourself. Has anybody ever used Nmap? Network mapper? There you go. Just about everybody has. Yes, use that against your network. See what's open, right? And only expose what's absolutely necessary. In most cases, it's just going to be HTTP, so port 80 and port 443. On TCP 480 and TCP 443, right? So now we're going to look at diversifying your attack surface, and here's what I mean by that. Your business could have different manifestations of an online presence. And I recommend using dedicated host names or even dedicated domain names for each one of those manifestations. So, for example, you could be running an API, right? The API is not end-user facing, right? It's like your app that's going to consume your API. That thing could be on its own domain, right? I recommend putting it on its own domain, even more than its own host name. At least give it its own host name for sure. But if you give it its own domain, it gives you more mitigation options that we're going to look at a little bit later. So then you have your marketing website, right? That's like your brand, right? www.yoursite.com. You could have a commerce portion of your site. So you could give it its own host. Now, there could be some SEO advantages to put both the commerce and the content on the same host name. So you got to think about this, but if that's not too much of a factor, I do recommend putting that on its own host name as well. It could be a SaaS service, you know, app.yoursite.com, right? It's software as a service. It's like a service somebody logs into, you know, to manage their expense reports, for example, right? So the thing about each one of those things is you got to look at what is the revenue impact of each category, because there are different mitigation solutions, right? So for an API, you're going to get revenue from app purchases and subscriptions. From content, you could get revenue from cost per click or, you know, display ads. Marketing, you know, it could just be to drive signups for your SaaS service, right? So you may have a higher tolerance for your marketing website being down. Maybe, maybe not, but it's something worth considering. Commerce, you would get revenue from purchases, right? SaaS, revenue from subscriptions. So with each category, you're going to have its own host name or its own domain name, and by doing that, you can have a different infrastructure backing each category with different mitigation solutions as well, right? And since each category is going to have its own revenue profile, you can tailor how much you're going to spend on a mitigation solution and infrastructure for that category. Okay? So basically what I'm trying to say is try to not put all your eggs in one basket. By diversifying a little bit, you give yourselves more options. All right, so DNS redundancy. I have a link to this article by EasyDNS. It's really well done, so read it. But I have kind of a summary of it. So yes, Twitter got taken down because their DNS provider, DNS, got taken down. And the world got more productive. But they could have avoided the outage if they had been adequately prepared with this very simple technique, which I'm going to show you. It's called DNS sleeper cells. So what you do is you can work with several DNS providers. And what you're going to do is you're going to assign one of those DNS providers as your current provider in your registrar. So anybody uses when you do a whois on your domain and it shows the DNS servers, right? You set that at your registrar. So you're gonna put your first DNS provider as your authoritative name server, right? So now, when the primary, if DNS goes down, for example, right, you can go into your registrar and now you can switch to a secondary DNS provider. And this switch actually happens in seconds for the following TLDs: .com, net, org, biz, info. So if your website is in one of those domain names, if you change the DNS provider for your website, it's near instant. Okay, so if your DNS provider gets taken down, you can switch to another one and boom, you're back online. Twitter could have done that. And they were down for like a whole day or something and they could have avoided that. They didn't know how to do it. So this is what it looks like. You have, yep. They could try to DDoS the registrar. There are two components, right? You have your registrar and you have the root servers. Okay? The root servers are very hardened. That's not to say they could not be taken down, but if the root servers get taken down, I mean, nobody's doing anything on the internet, like period. It's not even Twitter being down, it's everything being down. At least, unless you rely on host file to connect to everything, right? So yeah, I mean, that's a good point, right? But yeah, if the root servers get taken down, then it's game over. But so what you can do is basically set the primary provider, could be DNS, and your registrar. And then what you can do is have regular zone transfers with all your sleeper DNS providers, right? So you can switch to any one of them in an instant because they're always constantly mirroring. Yep.
So that's how you keep your cache? In other words, you're forcing these to recache each time? Is that why you're rotating them?
It's not so much about caching, it's to make sure that your primary configuration is constantly being mirrored through like sleeper DNS providers, right? Yeah. So that what happens is if somebody takes down your primary DNS provider, then you can switch to your backup provider. And if somebody takes that one down, you can go on and you can keep going, right? You got dozens of robust DNS providers out there, so you could have like a really, robust setup. And nobody knows, which ones you're going to switch to, right? So, yeah. Cool. So if you shop around for DNS providers, there are quite a few of them out there. Try to look for somebody who's got an Anycast infrastructure. Anycast is a way to route traffic in a way that's agnostic from geography. So you could have one IP address that is actually that will distribute traffic through a bunch of different servers around the world. So Anycast kind of allows you to do that. So try to, provider that has good geographical distribution with a rich feature set, so you can do things like geo-based load balancing, if you want to have different application point of presence. I would stay away from famous DNS providers who say, oh, we have all these famous clients, because if they have famous clients, then they're probably a big target. So, you know, when they say we have famous clients, it may not, I would not necessarily consider that a feature. You know, yeah, something to keep in mind. So, and if you're working with DNS, I would recommend whichever provider happens to be working right now, try to throw kind of pingdom or status cake monitors on your DNS services. Okay. And so, you know, you can keep track of the performance and availability, and then if you see any deviations, you can set some alerts, because it could be a symptom that they're being attacked. And then you can be ready to switch to your backup provider if they are being attacked. Okay, so now we're going to look at web performance and scaling. So, to me, it makes little sense to kind of go all in on mitigation if we don't have kind of basic performance on our application, right? If it takes like 4 seconds to, you know, spit out an HTML page, you know, you've got problems you should probably be looking at, right? So to me, performance is kind of foundational. And then once you have performance set up and you've gotten rid of all the obvious bottlenecks, then you can look at your scalability profile, right? You know, can you add more hardware to your infrastructure and scale that way? And once you've got that done, then you're much better placed to do mitigation. Okay, so I just kind of wanted to show this kind of foundational pyramid before we dig into performance. So I have a link here to, if you're using, is anybody here using Nginx?
Yes.
Okay, all right, cool. So yeah, Nginx, really high performance HTTP daemon, which does a lot more than just kind of serving files. So I have a link to configure it for really high throughput levels. There are a bunch of configurations you can do for that. If you're using gzip compression, it's good because it's going to reduce the amount of bandwidth that you use, but it also adds a little bit more CPU load. So you want to kind of tune that carefully. If you're using a database, make sure that you have indexes in your database that are well aligned with your queries. Often you have database queries against multiple columns, and you may have only one index on one of the columns. But that one index will return, you know, 20,000 records, and then you're still doing a row scan over 20,000 records. And most often you just need to make an index that covers 2 columns, for example, right? So you got to be mindful of that. You got to try to, you want to do whatever you can to reduce the amount of database queries that happen in the life cycle of a you know, page request. If you're using an RDBMS, make sure it's backed by some solid state drives, right? I don't think anybody anymore uses mechanical drives, but if you do, definitely consider SSDs. Table locks. So for a long time, the default table engine for MySQL was MyISAM. And what MyISAM did is whenever any write would happen, any write operation would happen to a table, it would lock the entire table. So then you would get like hundreds of read operations that would kind of get backed up until this write would complete, right? Thankfully, MySQL switched their default table engine to NODB. But if you still have anything that's running MyISAM, definitely look out for that and try to switch to NODB. Okay. If you're using PHP, try to have off cache configured. So a thing I like to call out, right, because you may start out and have these things done, right, at once, but then what will creep back up are these 2 lines here. Database indexes aligned with queries and the number of database queries per request, right? Because you're managing an application, you're always releasing new features, and people forget to put indexes on things. And people start making suboptimal queries, and they're adding 20 queries just for this feature on this one page, right? This will happen, this will creep up on you, right? And the developer often will forget to catch this, right? And then it goes live in production, and suddenly it's like, well, the site is down. Why is that? You know, why are pages taking 10 seconds to load, right? Well, you added a new feature that doesn't have any index, so you're doing row scans over hundreds of thousands of records. Because in production, you have a lot of data. In development, you often don't, right? And this is where things bite you in the butt. So you just always be mindful of that. All right, so that was performance. Now let's look at scalability. This is like an old graphic from Amazon AWS, kind of showed you how to scale your infrastructure. Quite simply, if you're using a database, try to make sure that your application is compatible with a master replica kind of setup, where you can have a master database for all write operations, and then a pool of replicas for all read operations, okay? So here you go, that's kind of that. So you can scale your data layer that way. Redis, has anybody here used Redis before? Yeah, quite a few. Cool, there you go. So you can add a caching layer with Redis. Web servers, it's nice because you can add a lot of web servers pretty easily. So Nginx is really high performance, but you can do it with any web server. Varnish, I love Varnish because so you can actually do quite a bit of caching. You can do pretty complex caching rules with Nginx. It's pretty amazing. With this said, Varnish has a much richer vocabulary, and it even has like an HTTP verb called purge. It has an HTTP verb called purge that allows you to purge individual resources. So yeah, I highly recommend Varnish. You can have multiple of those servers. And then if you're using static resources, obviously try to use a CDN. There are a lot of really cheap CDNs out there that do the job really well. So there's that. So that's for your scalability profile. All right, so now let's look at monitoring. You want to know what's going on. Has anybody here ever worked with either New Relic or App Dynamics? Okay, yeah, they're not cheap solutions. They're definitely expensive, but they give you pretty phenomenal insights as to what your application code does. It'll show you all the database queries, all the classes and methods are being called and how much time you're spending on those. Like it'll do real-time profiling, and it will keep track of historical data over time. So if you do a new release and you introduce a performance bottleneck, you'll be able to pinpoint that event to that one release, right? And it'll show you what it is that you introduced that causes bottleneck, right? So these things are pretty great for performance monitoring. But otherwise, you can also monitor ongoing availability with really cheap resources like Pingdom and StatusCake, like I mentioned earlier. They're great. Zabbix is an open source framework to monitor anything on your network. You can literally monitor the mood of your whole infrastructure with Zabbix. It's got great dashboards. Anything that throws SNMP packets, it can graph those for you. So Zabbix is great. Load tests. Please conduct load tests, right? If you can't survive 1,000 concurrent hosts, odds are good you're not going to survive a DDoS attack. Okay, so with loader.io, you can do up to just under 10,000 concurrent hosts for free. So it's pretty amazing. And then they have like paid tiers when you can do a lot more than that. So I highly recommend them. All right, so another thing for monitoring is, because sometimes you may get DDoSed and you may not have all those Zabbix and all those things in place, right? And you were down for the entire night and maybe most of the day because you got busy with other things, right? And no customer called you about it, right? You can always look at Google Analytics. You will see dips in traffic from Google Analytics, right? So just monitor that. There's also Google Webmaster Tools. it'll show you when the Google crawler can't crawl you anymore, right? These are all, signals that you can get, after the fact if you got DOSed. So hopefully you catch ahead of that, but, these are good stopgaps. All right, so now we're going to look at mitigation platforms. When it comes to mitigating attacks, there are two things. One is network attacks, right? We looked at the low-level network attacks, right? TCP handshake and all that good stuff. The best thing you can do with network attacks is absorb them and kind of discard them, right? That's really all you can do. Now, for application attacks, like HTTP floods, those are very hard to mitigate, and pretty much all solutions out there will do one of those three things. They will try to use some rules to block those attacks, but of course, beware of false positives, right? They might try to use throttling. It's like, oh, this URL is getting popular, but let's try to throttle all those requests, right? Caching is also a very viable strategy, right? But again, if all you're doing is caching, you could be eating up, and you're able to serve hundreds of thousands of response per second. I mean, your bandwidth bill is going to be, really high. So these are all things to keep in mind. So, let's look at a mitigation platform, right? You have your network and services. Hopefully, they're only exposing HTTP and nothing else, okay? And you're going to put a mitigation platform in front of it to be determined. In this mitigation platform, we're going to look at two things. We're going to look at what it could be if it's a do-it-yourself solution, okay? Or if you're using vendors. So let's look at a do-it-yourself solution. And my goal here is you get your network and services, with just HTTP. My goal here is to put a Linux gateway in front of it, right? You try to shield yourself with a really beefy, Linux gateway that can do all kinds of things. So what would it do? It would try to absorb network attacks through a combination of fine-tuning of kernel settings, as well as IP table rules, and as well as kind of traffic shaping with IP tables. And then when it comes to application attacks, it's going to try to absorb, scale, or block those application attacks. So to block, we're going to look at a couple solutions that do kind of a HMAC-ish kind of bot challenge baked into HTML payloads. The nice thing about most of those HTTP robots is that they're very, very dumb. They don't even accept cookies, don't even honor cookies. So there are a lot of things that you can do there to kind of make them go away. But of course, if you do that, you got to be careful because you don't want to block legitimate crawlers like Googlebot, right? Okay, so then there's caching. It's going to try to do caching and then load balancing across multiple web servers. So I have a link here to a phenomenal article on javapipe.net that shows you how you can, it gives you an entire sysctl conf to tune your kernel settings, and it gives you a big old list of IP table rules to harden yourself against low-level network attacks. So yeah, it's great. And what they're saying is, because they've had a lot of experience mitigating attacks, and they're able to block DDoS attacks at the network layer at line rate, right? So if you have a gigabit Ethernet link, for example, they can block it at, that line rate. So now we're going to look at a bunch of Nginx resources. Nginx is a phenomenal Swiss Army knife of a tool. It can act as a frontline load balancer. It could be also a caching reverse proxy. So I have a link here on how to configure that. If you want to put complex rules in Nginx, based on different aspects of the request, if you look at an attack that's coming in, if you see that they have some silly user agent, you can start using the Lua module to do some more complex rules on the requests for Nginx. Here's a link to a module to limit the number of HTTP requests per IP, but that can be very dangerous because now clients, legitimate clients, will use a lot of simultaneous connections to get stuff from your site. I have a link to a tool called Robu. It hasn't been touched in a while. Test Cookie Nginx module does still look pretty good. And so it'll send a cookie challenge to the requester, and that's pretty effective at blocking a lot of HTTP attacks. So then I have a link to set up caching on Nginx, and then a link to calomel.org. So that site is down. I've been looking at it the last couple of days. I'm hoping they're going to bring it back up. But they had like such a great article on tuning Nginx for a high throughput. I never took a snapshot of the article, so but to this day, it's still the kind of the best ultimate resource. So I hope they bring it back up. All right, one thing I like to do is limits.conf. Earlier we talked about ulimits, the amount of concurrent sockets that you can have. This is kind of what I do to mine. I just kind of put all the higher limits. It may or may not be a great idea, but it's been pretty good for me in most situations. So that's kind of what I do. Oh, here. You got it? Okay. Joe was. All right. Now, if you're using one of those tools to send a cookie challenge, make sure that you don't keep it on all the time because you could be blocking search engines, okay? And while this challenge page is on, try to make sure that the page is served over a 503 response so that if a search engine happens to hit your site at that time and they get that page with just a piece of JavaScript on there that sets a cookie, right, they don't think that that's your site now, right? So if you put a 503 status code on that, you are clearly signaling to anybody, especially the search engine, that, hey, this is a temporary state. This is not what my site is about, right? And so you're less likely to lose ranking, okay? That was what I just said. All right. So that was kind of a concept for building a do-it-yourself solution. Now let's look at working with vendors. Let me show you a little tale of fan DOS. So back when, I lived in LA, and it was one of the Star Wars movies that was coming out, right? And I wanted to buy tickets for it. So I went to arclightcinemas.com, and I'm just kind of browsing the site, and I'm making my way through a ticket, and I'm just about to purchase the ticket, right? Right? And just as I'm about to purchase the ticket, boom, I get this page, right? This page which advertises DOS arrest protection. I'm an end user, and I'm seeing a page about a vendor, right? Telling me that 429, I have made too many requests. Too many requests. It says, please wait 5 minutes before retrying your request. No. And I did wait because I really wanted to buy those tickets, right? But for your average commerce where conversion is everything, you want to be careful about this kind of stuff, right? So 429 status code is always a terrible fit for end users. You don't want to be sending that status code because you're telling them you have made too many requests. No, that's just not cool. The end user doesn't care about that, right? Now, if your service is an API, then yeah, okay, 429 does make sense, right? Because the clients for your API, they're not end users. It's software, basically, right? But if it's end user facing, make sure that you use 503 because again, 503 means it's currently unavailable. It's a temporary state, and you can make sure that you have a friendly message on top of that, right? So when you're working with vendors, make sure that you see what the failure modes look like. make sure that you control them and you can configure them, right? You do not let them advertise themselves to your end user, okay? You're not paying them $100,000 for a silly appliance, just to advertise their brand, okay? Make sure the messaging is always friendly to the end users and that you're using helpful status codes like 503 so you don't hurt SEO as well. And you want to, like I said, obfuscate your vendor solution. Because the other thing is, it's not just for the end users, right? Of course, the end user doesn't want to know that you're using DOS arrest to stop DDoS attacks. You don't want to give your attackers too much intelligence as to what solutions you're using, right? That's not to say that obscurity is security, but you don't want to make their lives, too easy. So yeah, look at their strengths and weaknesses across these three axes, right? How good are they? How good is the solution going to be at absorbing network attacks? How good are they going to be at mitigating application attacks? And what's their operational overhead, right? Because often when you explore DDoS mitigation solutions, they'll, especially sales folks, will kind of tell you, oh yeah, no, it's hands off, right? But then when you get into it and you start testing it, you realize that you have to tune it quite a bit because you're going to get false positives, right? They all advertise super advanced algorithms, to detect the bad actors, and it's all guessing. It's statistics, guessing, and it's going to be a lot of false positives no matter what, right? So make sure you test it, and to get rid of those false positives, that means you're going to have a good amount of operational overhead to interact with it, right? So in my experience, appliances are really good at absorbing network attacks. They do suck at application layer attacks, and they're not very hands-off. Then you get your cloud proxies like, Cloudflare. You guys used Cloudflare before? Yeah. So to me, that would be kind of my first go-to, really, just because they're very cost-effective and they're, you're not going to beat them when it comes to like blocking network attacks. And they have like massive network infrastructure. They're pretty phenomenal. They're pretty hands-off until you start getting application layer attacks. And then that's when you have decisions to make, right? You could go in there and turn on their, their challenge page. I don't know if you've ever visited a site that says, oh, hold on, we are verifying automatically that you're a human. And you see kind of this interstitial page that kind of sits there and it makes your browser do things to verify that you're a human. So it's, you don't have to decide whether or not you want to do that. And in those cases, mitigating application attacks is not going to be great. Okay. And if you're doing a do-it-yourself solution, you're probably going to do pretty well with network attacks, assuming you have a pretty good upstream network, and you can mitigate things at line rate with the configs that you saw on javapipe.net. And then you might do pretty well also on application layer attacks, assuming you can turn on that module that does a challenge whenever you do get attacked, but it's not going to be very hands-off, right? You're going to be maintaining the solution, and you're going to be writing scripts to turn it on and off and trying to automate it as much as you can, right? So that's kind of a bit of the landscape of solutions are out there. Yeah, never mind. And so conclusions. You want to, whatever you go with, whatever you do, you want to try to plan early, right? So see what your vulnerabilities are, kind of what might motivate somebody to take you down. What kind of network and services are currently exposed? Can you close them down? And then do whatever you can to harden yourself, right? With this kind of 5 pieces of strategy that I just outlined earlier. And try to engage vendors earlier rather than later, right? Because the worst possible time to engage a DDoS vendor is when you are under attack, okay? Like, they're going to look at your pockets and they're going to be like, huh, how deep are they? Okay, and they're just going to go in there, right? And it's fair, because, that's what people do, right? And they're there to be in business, right? They're not going to give you, so you want to try to have an early relationship with them. So you look at some kind of monthly fee, that you can afford, and that kind of has your back, right? So yeah. And then try to advocate for plugging attack vectors, right? All these open resolvers and spoofable networks and, open WordPress. If you can kind of let people know that don't do that, that'd be great. That's all I had. Thank you. Appreciate it.
Thank you, Chris. Wouldn't mind opening the browser?
Yep. Were there any questions?
You didn't mention any honeypots or anything.
No, I did not mention any honeypots. I know Cloudflare runs a bunch of them. Which ones do you know of?
I'm just curious.
Okay. Yeah. Yeah, well, because, there are a lot of, bots out there, and, people will try to put, honeypots to try to detect them. And I know Cloudflare has done a lot of that. It was like before even they went live with their services, that's kind of how they started. They were kind of mapping a network of kind of bad acting bots out there. It was pretty cool. I've worked with another honeypot project. I forgot the name of it. Sorry, it escaped me. Any other question? Yeah?
So, obviously you brought up Cloudflare, and they're well known for helping with DDoS attacks. But one thing I'm not sure about, is the capabilities they have fundamentally different than like what Akamai does or other CDNs, or are they effectively just a CDN that's marketed themselves with a focus on DDoS?
Cloudflare has a WAF and everything built in, so.
Yeah, and Cloudflare does a lot of things. So, for example, they have their own DNS resolvers that end users can use. So, the same as you have kind of the Google DNS resolver, like 1.1.1.1, 4.4.4.4, right? Cloudflare has their own as well. And it automatically filters out like bad sites, like compromised sites. So they do a lot of things when it comes to InfoSec related things. That's kind of one of their core heritage, whereas Akamai's heritage started out more as kind of just pure play CDN, and then they've added some InfoSec features, and then Cloudflare started more as InfoSec, and then they added kind of CDN, a lot of CDN features. So I do know that Akamai is really expensive, and usually their pricing is not transparent at all, right? Versus Cloudflare has really transparent tiers of pricing. So to me, they're, as far as kind of cloud-based solution for both kind of performance and security, I would kind of gravitate toward them. And I'm not getting any kickbacks from them. Okay.
Another nice thing about Cloudflare versus a lot of other CDN providers is they don't charge you for bandwidth until you get into like the thousands of terabytes or petabytes of bandwidth each month.
Mm-hmm.
So yeah,
Unless you want them to route your traffic over their internal network, which it's supposed to be better quality